Hello, hello. In this lecture, we'll be dealing with molecular mass. It's a quite important part. It is quite easy to learn, but it's quite important. If you don't know how to find the molecular mass, you won't be able to do any problems in stoichiometry and the mole concept. Okay, first of all, what is molecular mass? Molecular mass is just the mass of the molecule in atomic mass units. As you can see, I've installed a periodic table with atomic mass. The atomic mass is written down here. I'll written. This one is the atomic mass. This one, yeah, the down one, the down number. Okay, it is the unit over here. For example, we'll take nitrogen. Nitrogen is 7. Sorry, 14. 7, right? So this 14 is the atomic mass, and that the unit of that mass is in AMUs, atomic mass unit. And we'll have a proper explanation of AMU when we go on to Avogadro's number and the mole concept. Okay, now first we'll start finding molecular masses. Now let's take a simple compound first. Let's start with H2O. H2O. Now we need to find the molecular mass. What is the mass of hydrogen? The mass of hydrogen is 1. So 2 hydrogen. Therefore 2 plus. What is the mass of oxygen? The mass of oxygen is 16. Okay, 2 plus 16. 18 AMUs. AMU. That is the molecular mass of H2O. Now, as you can see, you may have a periodic table, and in that the atomic mass may not be a constant. This is actually the approximate value. A different kind of a periodic table with the approximate value, and you might consider that how come the atomic mass can be in a decimal? It's actually the different elements have different isotopes, right? It's actually the average of the atomic mass of the isotopes. That is why we have a decimal. We have decimals, but this one it's actually the average atomic mass. It's actually the rounded off one, approximate one. Okay, second one. We'll do another one. H2O is quite simple, very simple, right? We'll do another one, a bit more hard. Benzene, the one which we dealt with in the last lecture. C6H6. Now this is quite difficult, I see. What is the atomic mass of carbon? The atomic mass of carbon is 12. 12. Therefore 12 into 6 plus, what is that of hydrogen? We saw that hydrogen has an atomic mass of 1. 1 into 6 plus 6, right? Okay, what is 12 into 6? I'll do it in my mind. 72 plus 6, 78. Oops, I'll do it in another color. 78 AMU. Now that is the atomic mass, the molecular mass of benzene. Now another one. We will do glucose. It's quite hard, we have a lot of numbers in glucose. Okay, I'll do it anyway. Glucose, third one, right? Glucose. Now what is the formula for glucose? It's C6H12O6. We dealt with it in the last video. Okay, now what is the atomic mass of carbon? I actually forgot it. 12, yes, 12 into 6. We actually did it. 12 into 6. 72. 72 plus hydrogen, it's 1. So 12 plus, what is oxygen? I know oxygens, just to make sure. 16. 16 into 6. 16 into 6. What is 16 into 6? 16 into 6 is 96, right? 96, yes. So what is 72? 72 plus 12 plus 96. We have it as 180, right? 180. um 180, right? Okay, 180 AMUs. Yes, that is the molecular mass of glucose. Now we will be moving on to a different type of problems. First let me clear this. Cleared. I'm also clearing this heading. Okay. Yes, here is a question. I'll write it down. I don't want to write it with a sketch. Okay, I don't want the underline. Oops. What percentage of benzene is C? It's yeah, that's a question. I don't have pretty much to say. Okay, let's get into the question. Now, what is benzene? First of all, we'll write what is benzene. It's C6H12. Now, you might actually have a tendency to think that sorry, it's not C6H12, C6H6. You might have a tendency to think that carbon is 6, hydrogen is also 6, so that there are 6 atoms of carbon and 6 atoms of hydrogen. Why can't it be 50%? No, but that's not right, because the mass varies. Okay, first of all, we need to find the mass of the 6 carbons in benzene. What is the mass of the 6 carbons? What is the atomic mass of carbon? The atomic mass of carbon is 12. What is 6 into 12? Is 72, right? 72. That is the atomic mass of C6. Let me put an M over here. What is the atomic mass of C6H12? Total mass. We need a dividend, right? No, sorry, divisor. I actually get confused between them. Okay, whatever. C6H12. We have 72 plus 72. That is C6. Okay, I made that mistake again. It's not 12. It is how much? It is 6, right? C6H6. Okay, C672 plus H6. H6 will be the atomic mass of hydrogen is 1, therefore it will be 6. Therefore C6H6 is 78 AMUs, right? 78 AMU. Now we need to find the percentage. That will be C6 mass by C6H6 mass into 100, right? That is the percentage. Now I'll do it in another color. It's getting a bit boring. What is the mass of C6? It's 72. 72 by 78 into 100. Now I need my calculator. Let me take it. Okay, 72 divided by 78 into 100. 92.3. 92.3 percentage. Yes. So for 92.3 percentage of benzene is carbon. So hydrogen has, even though there are 6 atoms of hydrogen, percentage of hydrogen in benzene is quite low. See, makes a big change. Okay, now moving on to another problem. Okay, a similar one. Let me remove this first. What percentage of benzene we need? We don't need that. Okay. What percentage of H2O is? What percentage of H2O is? Oxygen. Okay. I'll write it in caps. Oh. Okay, we'll do it in a similar way, right? Okay, first of all, we need to write H2O over here. Alright. It's actually wrong. I should have written like this. Okay. H2O. What is the molecular mass of H2O? Oops. Messy. Molecular mass. I'm kinda weak in this. Of H2O. What is it? 2 hydrogen, 2, right? Plus oxygen. Oxygen is where is it? Yeah, 16. So the molecular mass of H2O is 18. Now we know that of oxygen is 16, right? O mass is 16. Now the percentage of oxygen in H2O, which will be the OM divided by H2O mass into 100, right? Now what is that? I'll do it in another color. Quite a different color I need. Okay, what is OM? 16, right? I don't like this color. 16 divided by 18 into 100, right? Into 100. Now I need my calculator. You know, even though it's a simple calculation, your calculator reduces the time. Okay, into 100. 88.8. We'll approximate as 88.89. 88. I'll do it in another color. Oops. 88.89 percentage. Therefore 88.89% of H2O is oxygen. So now I've run out of time. We'll do some more problems in the next lecture. Okay, bye.